Welcome back, listener, to another exciting episode. We will be discussing about cloud programming with a game-changing language, WingLang. I'm your host, Huzaifa, and today we have a cloud expert with us. Please welcome our guest, Elad, co-founder of WingLang. Kindly introduce yourself, Elad, and tell us about what you are up to.
Hey, nice. Thanks for having me, man. It's good to be here. I
Yeah,
love your background, all the building.
yeah, thanks, man.
Uh,
And
so,
it's a pleasure to have
go ahead.
you.
I'm Elad. Um, I live in Tel Aviv. Um, 43 years old. I have twins that are 5.5 years old, and I'm the founder of a company called Monada, which was founded about a year ago after I left Amazon. I worked at Amazon for about 7 years, and built. Last thing I've done there was build the CDK, the AWS CDK, which was a really amazing project and really really fun to work on. And basically, one of the things that happened as I saw people adopting the CDK and companies adopting the CDK, I realized developers still don't have the right tools to build cloud applications. The CDK is really great for defining your infrastructure and really changed the game in my mind, at least for me as a developer. But when you're thinking about cloud applications, they're not just about the infrastructure, right? Like they're about the infrastructure and your application code. And I realized that basically existing programming languages, the languages that developers use to describe what they want the machine to do.
Yeah,
Um, they're all designed around the idea that the computer is a machine,
yeah, right.
So what we're doing with the first thing we're doing at Monada is we're building a programming language for the cloud, which is a very ambitious exercise.
Sure. That is quite extensive experience, like working in AWS for 7 years and working in cloud. So you have some great experience. So my next question is, can you share your expertise specifically in cloud computing? Like, what are the different sectors in cloud computing that you have explored in the past, and what is your knowledge in cloud computing? Because you have developed your own cloud language. So just to give the viewers background that where you are coming from.
Okay. Um, so actually, my first experience with cloud computing, it's almost impossible to call it cloud computing, but was actually at Microsoft.
Oh,
I've been at Microsoft for about 5 years, and we built a private cloud. It was before Azure existed, but we basically built an on-prem private cloud for enterprises to use. It's a long story, but it was actually a really amazing uh, experience because we actually had to build all the building blocks of the cloud on our own. Like it was kind of like the full stack, like building the distributed database, a NoSQL database, a compute platform, a deployment system, and so for me it was like a great way to like learn about distributed systems and the kind of like the new paradigm that is required when you're designing applications for the cloud. And then probably 7 years later, I joined Amazon, and one of the projects I worked on was actually at Amazon.com, not on AWS,
oh,
and it was in the search team. So they're doing, like, they're responsible for like the product search in the catalog when you're going to Amazon.com. And so they have this like really really complex and very important, obviously, system that takes almost all of Amazon's traffic. And in that project, so first of all, that was an amazing experience, just like learning about how this search index works, right? And
yeah,
how indexing works, and how like the difference between, indexing the data and serving the data and the scalability concerns and everything. But it was also an opportunity to we actually built this like really large scale big data ingestion system that ingested all of the traffic that came into the Amazon website and calculated which products are more likely to be needed in the search results. So it was kind of like this pre-caching system.
Got it.
And we did it using serverless like Lambda, Kinesis, Dynamo, kind of modern, let's call it modern AWS. And so that was another type of like cloud experience. And in a sense, that's how the CDK was born, right? Like building the system was, my first experience using infrastructure as code. And I was like, I'm not going to copy and paste YAML all my life. This doesn't make sense. And I've seen that a lot of the responsibilities moved from the developer to the infrastructure. And so the CDK was my attempt to like bring back some of that kind of like expressive power that programming languages have to the infrastructure, right? Like that was kind of like that step. And then the last project was the AWS CDK, which, as I said, was kind of spawned off of some tooling that we've built for the search project. And that's basically, CDK is, are you familiar with the CDK? Is
Yeah,
like,
I'm familiar with it. So I think, yeah, that is quite some experience in cloud programming. So no wonders you are now up to the next challenge of creating an amazing cloud programming language.
yeah,
So,
by the way, one thing that I forgot to mention is that we, at some point during the CDK journey, we spinned off CDK for Kubernetes.
oh,
And
great.
so I actually spent a couple of years learning about Kubernetes and like understanding, kind of like, it was really interesting to understand the differences and how, the different, the fact that the cloud and industry is kind of like divided between serverless and Kubernetes, or like the AWS versus Google type
Yeah,
um, philosophical differences. So kind of trying to create a unified model for that, which is one of the things we're doing with WingLang, is to me, one of the goals, because I feel like you don't have to be in either a Kubernetes shop or a serverless shop, right? Like it's not an or
yeah,
situation. It should be an and situation, right?
yeah, totally makes sense. So, with that, my next question is, what are the key challenges developer face when programming for the cloud, and how does WingLang like solves all these problem?
So the way I'm thinking about it is like we have challenges both at the developer level and in the organizational level. So I'll start with the organization because it might be a little easier to, I don't know, just start with the organization. But basically, what we're seeing with organizations is that they're struggling in let's say, two fronts. One is the relationship between devs and ops, or developers and DevOps, or platform engineering and developers. Is like organizations are really struggling to like find the right organizational model that will allow each one of those disciplines to work independently. And the reason is because the system is really coupled, between the infrastructure and the application. And so when there's a coupled situation in the system, you can't really decouple the organizational story. And I think like a lot of organizations are struggling to map their existing structure that comes from like the days of the data center, where there was a really clear distinction between developers and operations. They really struggle to map that into the cloud because of that coupling, right, that exists. So that's one thing. The other thing organizations are struggling with is lock-in and decisions that have to be made very early, right? Like basically and it's, when I'm saying lock-in, I don't mean just locking into a specific cloud provider, which is definitely a huge pain, but also lock into decisions, right? Like, even the decisions, serverless versus container, right? Containers, you find yourself having to make this decision very early in the game, and it's really, really hard to change in the, as the system evolves. And I feel like that's not something that's not a good thing, right? Because because systems are changing and needs are changing and scales are changing and everything is changing. And the more you're able to make those decisions, move those decisions to become softer decisions, unless one of our team members basically said, you want to move, you want to change the decision from hardware decisions to software decisions, in a sense. And so the more you can actually delay or change those decisions later in the game, the more you're able to adapt to your changing needs. And so I feel like it's basically the lock-in and this thing about like having to make all these decisions too early. So that's from the organizational perspective. And from the developer's perspective, you're basically seeing a lot of frustration and a lot of kind of like lack of ability to be independent and to stay in a creative flow, right? And like you're finding yourself constantly having to go and deploy your application to make sure that it's working on the cloud, and then going to find the logs and why it's not working, and then going back and rebuilding and redeploying. And so that's something that, for me, as someone who grew up in the 90s and used, Borland C++ as a kid, I want to go back there, right? Like for me, like that's weird that we have a worse experience today building code than I had in the 90s. So this is my kind of inner child trying to, and I think the other part with developers is what we call leaky abstraction, right? Like the developers basically find themselves having to understand too many layers of the stack, right? Like as a developer, you don't really care if a bucket is encrypted or if your VPC has the right configuration. Like these are not concerns, these are not functional concerns, right? Like they're not part of like the functionality of the application that you're building. You really want to build your application. You want to put a bucket here or a queue here and a function here and a stream here and connect all these things together so that they actually create some value to your users. But you really don't want to care about all the underlying details. And today you really have to, right? Like you can't build applications for AWS without understanding what IAM policies are. And that's not really something that the developers want to understand. It's also not something that the platform teams want developers to deal with, right? Like, so it's kind of like this weird situation where developers have to like deal with a lot of crafts, a lot of mechanical details that are not really adding value, right? Not to them and not to the org. They're just creating more opportunities for mistakes and security problems. And so, and again, it goes back in my head, it goes back to like working at the right level of abstraction, right? And I can give some more examples, but I'm talking too much.
Yeah, no worries. So you have made some valid points, because I also know, like, I also work in AWS a lot, and then like on the coding aspect as well, and then in the creating like architecture diagrams. So there is one more key challenge, that's these platforms like AWS, Google Cloud, these platforms are changing very simultaneously. Like all these things, they are like changing very rapidly. So you can find yourself like you are setting up like Elastic Beanstalk or like Kubernetes or something, and 1 month ago the configuration, that the whole UI was different. After a month it is bit different. So, and then also coping up with uh the coding aspect, the DevOps aspect. You're right, like you cannot like just learn coding and then like start developing application. Have to get the insight of how to set up like the infrastructure, how it actually works. Then you can basically create the right architecture for your application. So I believe like the developers are in a lot of stress, because you have to learn first, like I think a lot of languages, and then you have to learn like 4 or 5 different databases, then caching, time series, then on top of that cloud. So yeah, it is very stressful. So yeah, I think it is a good idea to just like what you can say, like abstract the whole cloud thing, so that developer does not have to worry about that. He can just like code that cloud aspect, rather than just going to cloud or worrying about that and stuff.
Yeah, I think my message is not that developers shouldn't worry about the cloud. It's basically that developers should have the right tools to use the cloud. right? Like in Wing, we actually have this, in order to import a library in Wing, you use the bring statement. And almost by accident, are, eventually the first sentence you write in every Wing program is bring cloud, because you're bringing the cloud library into your code and you're using types from that library, right? And I feel like that's kind of like the message, right? Like, is like, I want to bring the cloud into my code base. I want to use it as a developer, not use it as an IT engineer, right? Like it's a different type of medium, right? Expression medium. I'm happy to show you if you have some time.
Yeah, sure. You can just give a demo so that viewers can also see like how it works, because I know that the code and infrastructure both are like going simultaneously, both are together. So this is the most amazing thing about WingLang.
Well, let's see. Let's see if it makes sense.
For sure.
Give me a second. Sharing my screen.
Okay.
Not that interesting. Okay. Okay, so let's play.
Sure.
I have a few of those. Okay. So I'm gonna kick off Visual Studio Code.
Okay.
And we have an ID extension for Visual Studio Code. So that's like table stakes. You can't have a programming language without ID support. It's still disclaimer, right? Like Wing is still in alpha.
Yeah.
Open sourced it not long ago, and we're still developing. So it's a great time to like help shape it and help us, figure out what's the right thing to do about it. But it's definitely not ready for prime time or for taking to production. But it's already starting to show some signs of life, which is really exciting. And we're in a really cool stage of the project. So on the terminal, I'm just going to run wing it. And that's a funny little thing. And it will basically open what we call the Wing console, which is a desktop application that's, that you install on your machine. And it's kind of like your sidekick for building Wing applications, right? So
Great.
now, as I said, we're going to start with Bring Cloud, right? So now I've brought the cloud library. And if I do new, you can see that I have a bunch of resources that are part of the Wing standard library.
Okay.
And those resources are actually agnostic to the cloud deployment, the eventual deployment. They have names that are very similar to the AWS names or to like the kind of like common cloud names like bucket and queue and function, but they're cloud buckets, right? Like they're not an S3 bucket.
Okay.
And so they're an abstraction layer, right? And so let's start by creating a bucket, which is, I guess, like the most fundamental resource. It's AWS's first service, so I should probably start with that, right? And you see that as soon as I saved my file, I didn't have to like compile it in the background. I didn't have to like run some like multiple scripts connecting to each other in some like weird way. The console basically picked up this change, compiled my code, and also showed me the bucket here. And I can interact with it, so I can upload files and download files and do stuff with it at this point. Not too much.
Yeah.
But bucket is not that interesting because it's not doing anything interesting. Let's create a function, right? A cloud function. So a cloud function, when you compile to AWS, a cloud function becomes a Lambda function, right? As an example. And the parameter that the cloud function accepts is what we call an in-flight closure. So it looks like a closure, right? Like a block of code, but it has the in-flight modifier. And that modifier is, in a sense, is all of the news about Wing is here in this modifier, right? It's basically the idea that Wing supports both infrastructure and application code together in the same programming language. And so the infrastructure is everything that happens here, right? Like the new bucket is basically infrastructure. I want to create a bucket. I want to define a bucket in my cloud application. And my runtime code is the stuff that runs inside my in-flight closures, right? And so in this case, if I do hello world and I save this, now I have my little cloud function here and I can run it and I see hello world, right? Now, this looks like a toy almost, but the thing is, like, when I compile this to AWS, so I can compile it and I can specify which target I want. I can do Terraform AWS, Terraform Azure, Terraform GCP, AWS CDK. So you can actually be deployed through CloudFormation and not through Terraform. You'll see that the target now includes a bunch of resources. This is a Terraform file. And you see that it includes my IAM roles. It includes my Lambda function here. It includes my S3 bucket here, right? Like, so it basically translated my application model into the specific infrastructure for AWS.
Got it.
And so when it's running here in my simulator, it's all running locally on my machine. So I get this like really instant feedback. But now let's see the most interesting part, right? I'm gonna put the bucket inside a variable. And let's say I want to put a file in the bucket. So I'm doing beat dots, and then I see the API of the bucket, right? Like put, get, list, whatever, all these things. But if I do beat dot here, I see a different API. So this is basically what we call the pre-flight API of the object. And this is the in-flight API of the object. And that's a really important fundamental. Again, it's related to this in-flight, pre-flight idea that each object has a pre-flight interface and an in-flight interface. And when you're creating classes, when you're declaring classes in Wing, you can also specify the in-flight API of the class and the pre-flight API of the class. So your custom types, they also have these two interfaces. And so I think like it's starting to make sense, like what you can build with these things, right? Let's put a file in the bucket, okay? Hello world, okay? So now, as soon as I save this, you'll see that the compiler not only updated here automatically, but also sees the relationship between my function and the bucket, which is
That is very cool, bro. Like instantly, it is changing like instantly. And the part that you have write like just 3 lines of code, and it has like set up everything, like the IAM role, the whole everything, Lambda and their relation, everything. That is very cool. So yeah, go on.
Yeah, and so this relationship is not only a relationship, it's also qualified by the fact that I've done a put operation. And so when I'm actually compiling this to AWS, you'll see that the IAM policy has only put object permissions on the specific bucket. Because again, we didn't have tools that had the full picture to that point, right? And so having this full picture is the power of Wing, and it's the power of this tool as well, right? Like the ability to show these relationships. Let's see another small example. I promise it's not going to be too long.
Sure.
I'm going to do another third-party library for Redis, right? Like Redis is actually a really common thing to use in cloud development. And so now I'm going to do redis.redis, and I'm going to save that too. And now I have like a little Redis here. And I'm going to also call the API here, set hello world, right?
Okay.
And see that as soon as I did this, now I have like another error that shows that the cloud function is interacting with Redis. So it's not only for the core resources, like any relationship that exists, is the compiler understands it. And now if I call this function, I can basically see that now, I have my bucket here. And I also have like, if I click on Redis, you see that I get a command line interface for Redis, right? Because this is like a really useful way to interact with Redis. And I can see the contents of the key. And if this is compiled to AWS, it'll provision an Elastic Cache cluster and a VPC, and it'll put the Lambdas inside the VPC and make sure all of this is like wired up together with the right permissions out of the box, basically.
Great. And that
I can show you more, of course, but I think this is
on the command line, you get like the whole Redis functionality on the command line. The Redis, you can like play with it. That is very good. You can just like also check like what is in the instance. You can also play with it. Yeah, that is great. And about like, because you have now explained like about the lambda function, Redis, I know there's a long list, we cannot go into that, but about like EC2 instances, or like about like Kubernetes, or you can say that like in that domain, like it's also like you can also configure that using WingLang.
So the SDK still doesn't have building blocks for containerized applications. That's definitely something that we have on our roadmap. We do have a service high-level resource that allows you to basically create a long-running service, but we still don't have targets for AWS and GCP and Kubernetes, and so that's still coming up. Again, nothing in the architecture of this solution is blocking that from being supported. But there's something really interesting about the fact the Wing is built on top of CDK technologies like JSII. I don't know if you're familiar with that, but basically Wing can use any CDK construct as a first-class citizen. And so you could technically bring any CDK construct from like any Terraform provider. Let's say you have a Terraform provider for GitHub, right? For GitHub repositories, then you can actually load the GitHub repository Terraform provider into your Wing code and use it as a first-class citizen. So you can basically do, I don't have that ready as an example, but you can basically do new GitHub repository. And as
Oh,
soon as you do this, it'll plug in the GitHub repository resource into your Terraform output. And you can actually, reference it from your in-flight code with Terraform attributes. Like it'll take care of like the wiring of the attributes. And so to your question, even today, there is nothing you can't build with Wing in the sense of like which infrastructure you can use, which resources you can use, which cloud providers you can use, because the fundamental technology is basically just synthesizing Terraform configurations, right? Or CloudFormation configurations. And so you can use all of the Terraform ecosystem out of the box. I think the power is, creating these abstractions and these local experiences and all of that. But for now, we have there's nothing that blocks you from using any tool that exists today in the cloud.
great, great, great. I think that is a very insightful demo, and a lot of developers who will see this video, they will be really excited, like exploring Wing by themselves as well, because the main thing that I like about this is like it is very visual, so you can see like what is going on, the relation as you showed, like it is showing that this function is related to Redis, it is also related to bucket. And then on top of that, I was thinking like when the bucket is created, it has the access of all the functions. Then you said no, like I have written like dot put, so it only like in the IAM role it has only the put permission. So that is very exciting.
Yeah, and it gets complicated. Once you create your own abstractions, you can create classes in Wing, and classes in Wing can compose together lower level resources. So if I can create a class that basically allows me to, when I put a file, it'll put it both on Redis and on a bucket, right? Every time. But then the permission model will extend to that class. So when I actually call put on that class, it means that I actually need the permissions to put, a file on the bucket and to set a key on Redis, right? Like it's a composable model, which is obviously the essence of every programming language is its composability. And so composability exists in this context of pre-flight and in-flight and permissions. And so that was actually the hardest thing for us to build with, right? Like that's something that doesn't exist in
Yeah,
existing languages.
sure. And with that, my next question is, what sets WingLang apart from other programming languages? And is there any competitor of WingLang? Like, because I don't know about this, because I think like this is super cool, and I haven't like experienced anything like that before. But like, you know more about that, so yeah.
So I think the main novelty is this concept of pre-flight and in-flight. That's like, and I I don't think that there are existing programming languages that have the same concept. In a sense, it's kind of like preflight is almost like a macro language. It's kind of like it's a compile time language, right? Like, so we use the same language for the compile time and for the runtime, right? Like preflight is compile time. Is like the output of the compiler is a Terraform file, right, or a CloudFormation file. And so in that sense, it's not very different from like compile time. Zig, for example, is a pretty new language that has some really powerful compile time primitives. But Wing takes it to the next level because Wing's first class is compile time in a sense. And then these inflights are the runtime piece. And the relationships between the inflight and the preflight is the complex part, right? Like, for example, just as an an anecdote, like when you're referencing a constant string, right, like an immutable value string from an inflight function, then Wing will just take care of like copying this value into your Lambda bundle, right? Like, let's say I have like a config file and I'm just loading that config file during compilation, and I'm just referencing this config file as if it was just a normal code reference. In reality, what you need to do is you actually need to take this static information and bundle it into the Lambda function so that when you're running at runtime, you'll be able to use it. And so Wing takes care of like doing all of that, but it will also protect you from shooting yourself in the foot. So if you'll try to reference a mutable piece of information, Wing, the compiler won't let you, because you can't reference something that will eventually change, right? Because we can't copy the information and make sure that it's available at runtime. And so everything that's related to this in-flight and pre-flight is, in a sense, Wing's initial novelty. I think the other thing that's happening is, as we kind of like progress through the roadmap, we realize that there are many things in cloud development that we can do much better than existing tools do, because we're designing a language with the cloud in mind. And so, for example, everything that has to do with like working with JSON. So Wing has a primitive type of JSON, right? Because it is a primitive type of the cloud, right? Like, and being able to like natively interact with JSON and safely interact with JSON data is really important when you're building cloud applications. Same things for API specifications and metrics and alarms, and we're going to have like OpenTelemetry, built-in OpenTelemetry support, right? Like, you're not going to have to do anything. Like, you're just going to have OpenTelemetry instrumented into your code without caring about Open API. Like, so there are many things in the kind of like the roadmap of the language and the stack that are cloud oriented, we call them, like they're related to developing for the cloud, that we think we can like just bake into the language, bake into the SDK, so people don't have to like manually configure every time. And to your question about other examples, there are some languages that are referred to as cloud languages or cloud programming languages. But one of them was Darklang, which kind of pivoted a little bit towards AI recently. And there's Unison, which is another language that's kind of like referred to as cloud language. But I think like they're thinking about what's a cloud language is a little different than ours. And I think the main difference, again, is this pre-flight thing, is this infrastructure side of the cloud, which I think is Unison, I think, is really great for like networked and distributed applications, right? Like, it's designed for the runtime. So it's really good for the runtime side. But I think the unique thing about Wing is this connection to the pre-flight stuff.
Got it. Got it. So with that, I know that your whole WingLang language is basically right now in alpha mode, or you can say beta mode. Right now, you guys are working on it, but still, like, is there? Do you know anyone like who is actually using WingLang to generate the whole Terraform code, and they're using it, and they like tell you like, yeah, Elad, like this is something amazing. So is there any like case studies, like people who actually started using it, like for small applications as well? So
we have a production application that uses Wing.
oh,
It's a very stupid application. I think it's just not ready for that yet. Like, to be honest, like I feel like it's, I'm respectful of the process, and we're just not ready for that. We do have like this amazing community of contributors that are involved in the project, like way more than I expected at this point. And they're contributing amazing stuff, like really, like for example, all the AWS CDK support is contributed by the community. So there's definitely a lot of people involved, more than I expected, but I think like it's too early to actually look for production examples, right? Like it'll
Sure,
get there, but still not there.
sure, sure. And how does WingLang integrate with existing cloud platforms and services? Like, are there any specific tools, frameworks that works well with WingLang, or like, what is your future goal in that sense?
So as I mentioned earlier, Wing compiles when you compile Wing, you specify the provisioning engine that you want to use. It's almost like basically saying what type of instruction set you're using. Kind of like when you're compiling native code and you're specifying x86 or ARM, then you're specifying Terraform or CloudFormation. Eventually, we're going to have Kubernetes as an instruction set, right, as an output format. And you're also specifying the cloud provider, which is almost like specifying the operating system, right? Like when you're saying x86 for Linux or ARM for Mac, right?
Yeah,
And so the cloud provider is the operating system, right? It's like AWS, GCP, Azure. And so that's kind of like the foundation of when you're compiling. It's kind of like the base layer, and then on top of that, you can basically, as I said, use any resource that's supported by that instruction set. So if you're using Terraform, you can use any Terraform resource. And if you're using AWS CDK, you can use any AWS CDK resource. And eventually, we also want to support plugging in different implementations. So for example, the Redis example I showed earlier, the default behavior for AWS is to use Elastic Cache. But we know that there are many customers that want to use, the Redis.com service or some other service, right? Like to serve their Redis needs. And so Wing will currently doesn't yet, but will support switching those backend implementations, basically. Like the architecture is there. It's just like the developer experience is not nailed yet. But that's another really important thing for like enabling choice. You know what I'm saying?
got it, got it. Yeah, that is quite insightful. And with that, my next question is, what kind of learning curve, like you can say, like developers expect when transitioning to WingLang from traditional different programming languages? So, are there any resources or best practices that you guys recommend for developers, or is there like a particular documentation on your website, or like for best practices and stuff?
So we're actually working on documentation. The next month or so is going to be hopefully a big jump in like quality and content, and so that's definitely there is a getting started guide for Wing. And to your first question, I think learning Wing for someone who's used TypeScript, JavaScript, Java, .NET, Swift, any of like Kotlin, any kind of modern object-oriented language is going to be 10 minutes, 15 minutes, truly. Like we're really designing it to be a very, very familiar language. I mean, I showed you some code.
Yeah,
I doubt that I needed to explain the syntax, right? Like it was very straightforward.
yeah,
So the idea is that, you'd be able to read Wing without learning anything. Like it's going to be like, you just need to understand this concept of in-flight and pre-flight, which is the major innovation. But other than that, like reading Wing is going to be really easy for you. And learning how to write Wing should also be pretty straightforward. Again, we're really trying to make sure that the barrier for adopting this language is going to be as low as possible, and that you're going to get your excitement by building cloud applications and not by breaking your neck trying to understand language concepts, right? Like we're definitely trying to go on that side of the spectrum.
Got it. Got it. And can you tell us about like the scalability and performance aspect of WingLang? I know like it is right now like in the initial phase, but are you guys how you guys are like approaching to that? Like how you can like actually make sure that it also caters the scalability aspect? Because for example, like in AWS, you can set like auto scaling parameters, like once there is like a lot of traffic, another EC2 instance is added, or like it auto scales. So in that sense, how WingLang will like handle it?
So WingLang uses the cloud to handle it, right? Like that's the beauty. And so even today, when you're creating new cloud functions in Wing, they're all deployed through Lambda, right? Or through Azure Functions, or through some other, function as a service that you use. And so those services have scalability built in, right? Like that's the whole beauty of the cloud, is that you're able to like move some of those responsibilities from your application to the cloud. And so the idea is that Wing is going to be your way to express your architectures and use these tools easily. But then the heavy lifting of load balancing and scaling, deployments, and like we have amazing tools in the cloud to do that. And the idea is to make them more accessible and more easy to use.
Got it. Got it. That makes sense. And what security measures does WingLang have in place to ensure that there is like a safety in place in the cloud? Because like how WingLang make sure that the right security aspect is added in the cloud, like for instance in AWS, like how it makes sure that that WingLang interpolates or like get the right IAM policy to set in the AWS.
So there are two sides to this answer. One is it depends on the environment, right? Like in regulated environments and environments where you actually need to like make sure that there are certain protections in a sense from in a security networking perspective. I believe that the right way to enforce those protections is through tools that are available through cloud providers, like IAM policy boundaries in AWS, and other types of boundaries and config rules. And there are I'm familiar with the AWS, some of the AWS tools. I know that there are lots of tools in the Kubernetes ecosystem for that. And I think enforcing those constraints, those compliance, should happen at the platform level. Having said that, Wing has this really cool feature called compiler plugins, which allows DevOps engineers or platform engineers to vend a plugin that goes into the compiler and either enforces or applies certain concerns below the abstraction line. And so if, let's say your org needs to make sure that all your buckets are encrypted always, right? Like with KMS managed encryption, then I can vend a compiler plugin. And every time you compile to AWS, the plugin will go through all the buckets and set encryption. And so developers doesn't have to care about that, right? Like, because it happens during compilation in their CI/CD, for example. And still, I would still highly recommend enforcing those things in production, right? Because I feel like that's two different concerns. But it will actually create a situation where, by definition, the applications that are compiled by Wing will have that policy applied to them.
Got it.
So this is kind of like how I think this should work, right? Like I feel like there should be some design time support, which is these compiler plugins, but also some runtime enforcement.
Got it. Yeah, that makes sense. That makes sense. And how do you see WingLang contributing to the future of cloud computing? Like what you guys can do and bring in the market?
I hope that Wing is going to be a way for developers to access the cloud. I feel the cloud, in a sense, is kind of like not accessible to many developers. And I've talked to many friends of mine who are, building amazing things that are basically running on the cloud, but they're afraid of it, right? Like they would tell you, I don't want to deal with infrastructure. This is the DevOps thing, right? Like I just want to build my thing, my application. But the reality is that they're not really able to leverage the cloud, right? Like they get like their little corner and then they shove in their stuff. But then eventually, when they really do need something for the cloud, there's a new service that came out that can really make a difference, then they have to go and work with platform teams and DevOps teams. And like they really don't have direct access to this computing platform. And our mission for the company, in a sense, is like to unlock the cloud, right? Like to basically make the cloud more accessible, more democratize this technology so that more developers are able to directly use it. Because I believe in it. I believe that this is, a fundamental shift in how we're building software. And it's about time that there's going to be a fundamental shift in the languages that we use to build software, right? Because uh, languages haven't caught up yet.
Yeah, yeah. Like
It's a small vision, nothing.
yeah. No, it like a very good vision, and I would say I hope you guys like go a long way, because I remember like back in the days when there is not like AWS or Google Cloud, they are not very popular. So you have to like actually buy a Linux server, then install OS, and then there are like a lot of steps involved. You are even installing, like for instance, you are using cPanel or Webmin, or there are like a lot of like wrappers that you can put on a server, and then you deploy your application, even if you have to deploy a WordPress website. So it was very difficult. Now you can see like a lot of these cloud providers and a lot of hosting websites, like all that steps are now reduced. Like it is very easy. So I think like what you guys are doing is like taking it to a next level, that rather than just like going on the cloud and setting up everything and doing it, you can just like set up the whole infrastructure from your laptop. As you told, like the developers can also like do it, so there's no need in that sense that uh, a developer is like that is something that a DevOps guy should take care of. Like developers can also like take part in this, how the cloud actually works.
Yeah, I agree.
So that my next question is, what level of community support exists for WingLang?
So the first thing we've launched is the community. Like I really believe in open source, and I really believe that in order to build something like that, you need to collaborate with as many people as possible and get as much feedback and make sure that it's actually designed and built by the community. And those are, some of the things I've learned from my work on the CDK, which became like pretty big open source project and an amazing community around it. And so looking back, I was like, this is how I want to build software. And we actually have a pretty cool community already for this project. I think let me check. I think over like 600 people on our Slack already. And a lot of engagement, a lot of contributions already, as I said earlier. People are helping each other. People are excited and involved and giving us feedback on our RFCs and requests. So it's definitely very intentional, right? We're really trying to make this a welcoming community and a place where people can contribute their first contribution to open source, despite the fact that it's a programming language. There's a lot to do. And if anybody's interested in reaching out and helping out and working with us, we're here to collaborate with you.
So to just like just on that point, like how do you guys make sure that you guys have like a goal set that all the people, because I know like in open source project I'm also the one of the 600 guys in the Slack community. So how, how do you guys make sure that everyone who is working on WingLang is actually going to that particular one goal? Because a language has to, because you guys have a particular goal in mind that WingLang should do all these aspects. Right now like it is performing this sort of like things, but we
Right.
need to add this functionality. So how do you make sure all the contributors, everybody, because it is open source, are on the same path?
So first of all, they don't all have to be on the same path. There's a tremendous amount of surface and work, and whether this person decides that they need to they think that AWS CDK support is valuable, and they reach out and say, hey, I thought about adding that support. It was completely not on our roadmap for the short term, like definitely on the roadmap for the long term. And we were like, yeah, why not? Come on, go ahead and take that. And so that was a great surprise, right? Like I feel like that's one of the beautiful things about open source communities is that they really celebrate this organic evolution of software, right? And so this person who wanted the CDK support now changed this software to become something different, right? Like it's basically transitioning to become something that this person needed. And so that's kind of like the first answer. The second answer, we use this system called stories, where we write a little narrative that describes, where do we want to be in the next 2 weeks or 3 weeks or 4 weeks, or, step in a sense. And we describe it in kind of like in terms of like future, it's a future document. It's like, this guy is like walking into the project and can do these things, right? Like I can now build this stuff with Wing. And then we basically all work towards that goal. And so we decompose the story, and it was like, oh, we need this, and we need this, and we need this, and we need this, right? And we need if statements, and we need for loops, and we need, right? Like, so we basically have this, and you can actually see all of that in our documentation. We actually have a section that shows all of these user stories. and that's a way for us to kind of like at least have some general direction that people are working towards. And it's, we're actually at this point in time, we're actually like working mostly on quality. So we're not really even implementing new features in the probably in the next few months, or, like we're definitely like focused on like getting the quality to a point where it's like great, and that we can like announce beta, and we can get more people to like use it in production. And so that's our focus right now. So we're not using these stories at the moment, but definitely a really cool way to connect everybody together.
Sure. I will also paste the link of your community. Like if anybody wants to join, like who is watching this video and like who is interested, like you can just like join this community, and it is like very live because a lot of people messaging. There's a lot of communication, a lot of work going on. So it is like for developers like who loves to contribute to open source. Like I would say, like it is a great option. So yeah, with that, my next question is like, is there any notable design pattern or architectural consideration that developers should keep in mind when developing something like creating the architecture using WingLang? Uh,
Yeah, it's a good question. I think that, right, creating applications that run in the cloud, and that's kind of like related to something that we discussed earlier. I think we don't want to hide the fact that your application is running on the cloud, because there are considerations like, for example, distributed system behavior. If I'll give a simple example, right? Like when you're we have an API for the bucket that's called try get, and try get basically returns nil if the object is not on the bucket, and returns the object if it exists. And you could implement try get in multiple different ways. One way is to check if the object exists and return nil if it doesn't. And if it exists, then actually get the object. That's actually not the right way to implement something like that in distributed systems, because it's not an atomic operation, right? And so between the time you've checked if the object exists and the time you've actually retrieved it, something could have happened, right? Because it's a distributed transaction. And so the right way to implement this is to actually perform a get operation and handle a not found error and return nil in that case. So that's a simple example. But one of the things that we want to do with Wing is we want to educate people, right? Like we want to teach people how to build these distributed systems. And we've actually had this really interesting conversation today. It's like, what role do we have from an API design side of things, right? Like how do we make sure that the APIs make sure that people understand, have an empathy to these distributed system considerations, and also how we create the right content and educational content, because it's definitely not the same as building applications that run on the same machine, right? Like I feel like that's a fallacy, right? Like people who are trying to tell you that it's possible to actually build cloud applications without caring about the fact that the cloud is a distributed system. I don't really believe in that, because I feel like there are fundamental differences. And so to your questions, yes, there are, and I hope that we will be able to help people learn about them, because they're also really interesting and really
Yeah,
cool.
I think yeah, it is also like it is very interesting like project. I would say like I once the first time I like landed on that thing like WingLang. I checked the website, I like downloaded it and like install locally, like play with it. Like it is like very exciting, like for a developer like or a person like who is into cloud or into programming languages. It is like a very exciting project, I would say. So that is like a very good thing. Like it is not like boring in that sense, like a lot of configurations. So a lot of, so it is like exciting, so that I think like you will get a lot of user base of developers and DevOps guys, because of the fact that you guys have a very good like the whole UI and the code, and because of this.
I hope so. And please, I'd love to hear feedback, right? Like I feel like, as I said, it's very, very early. It's a great time to help shape this and make this awesome together.
I think like I can contribute in WingLang by creating like tutorials, like how different like sort of things works. Like as you showed, like a quick tutorial during this podcast, like creating an S3 bucket, like creating another Redis service. I think like I can contribute in a way by creating like few like 4 or 5 different videos along the way, and you guys are also evolving, and I can like put it on my social media, all the channels, and can help you guys grow on social media, whatever I can do in my reach.
That'll be amazing.
Yeah. And lastly, like my last question is, can you share any future plans or roadmap for WingLang development, including upcoming features, improvement? You have told me already that you guys are working on code quality and the quality aspect rather than the creating new features, but like in broader term, like in 2 years, 3 years, what you guys have decided, like what are the new features and things that you want to have in that WingLang language?
So I think basically, have the right level of support in terms of SDK resources. I think like the right level is the key word, and like we have to like understand exactly what's that surface looking like. And then having like support for different cloud providers and targets. So that's the other dimension, right? So that's one aspect of the roadmap, which is going to be constant work and constant evolution. I think the other side is supporting the various aspects of cloud programming, like I said earlier, like JSON and Open API and Open Telemetry, and creating web services, and creating containerized based applications, and creating workflows, and each one of those types of applications may influence the SDK, may influence the language itself, right? Like we could, the fact that we actually have control over the stack for the entire developer experience, starting from the programming languages to the to the ID extension, to the to the Wing console, gives us a lot of ability. It gives us an ability to actually solve problems that have been lingering in the cloud development world for many years. So a lot of stuff in that type of work. And then the other direction is going into production with Wing, right? Like is like giving you more and more support as the application moves to production, you can already deploy this to production and it works. But we believe that, with the information we have in your code, we can actually give you really better deployment experience, better operational experience, better testing experience. So all of those things are coming up.
Sure. Wise words, Elad, and thank you for sharing your expertise and shedding light on to cloud programming using WingLang. And we greatly appreciate your time and insights.
Thank you for having me, man. It's a pleasure. Thanks for all the good questions. It was super interesting.
Yeah, thank you so much for being on the show. Yeah, that brings us to an end of another exciting episode. In that episode, we discussed the cloud programming language WingLang. And until next time, have a nice day and keep striving. Thank you.
Bye.